Okay, welcome back. So in this video, we're going to review if statements in Java. So hopefully most of this will be simple and be a review, probably a good refresher for most of you. And then you might find a couple new things in this lesson. So if you decide to skip forward, be careful because there might be some things that we didn't talk about last year. So we'll start simple. I've set up a program here where it asks the user to enter an int, and I'm going to store that into A, and I'm simply going to use an if statement to say if A is less than 0, then I'm going to print line negative. Okay, and that's it. So that's the simplest if statement you can get. So this is just a single alternative if statement. So if this is true, we're going to print negative. Now, what if it's false? Well, it's just going to do nothing. It's going to continue on with our code, but we don't have any code there. If you wanted to, you could have a little message here that says goodbye, or you don't have to have that. So I'm just illustrating that you don't have to have an else statement if you use an if. Okay, so this program works fine. It should compile, and if I run it, so if I enter -5, it says negative, goodbye. And if I run it again and enter +5, then it just says goodbye. Okay. And then, of course, you can add an else. So this would be a two alternative if statement. So you might want to say positive. And some of you might have caught my my semantics error here, because this isn't quite a perfect program, but it works. There are no syntax errors, and when I run this, if I enter 8, it says positive, goodbye. And of course, if I enter a negative number, it works, negative, goodbye. But what if I entered 0? If I enter 0, it says positive, which is not really true. Well, it's not true at all. 0 is not positive or negative. It's 0. So we could add another alternative, a third alternative. So I'm going to change this to say, so if you want a third alternative, you can't just put another else. You're only allowed to have one else per if block. So I would have to change this second one to an else if, and then I have to put another Boolean condition. So a Boolean condition is a statement that can be evaluated to give either true or false. So here I'm going to say else if A is greater than 0. Then I'm going to print positive. And then I'm going to say else system.out.println 0. Okay, so now it will print one of these options, and then it would say goodbye at the end. Now, could you change the order? Sure, you could. You could do the positive case first, and then the 0 case, and then the negative case. Let's just pretend we did that. So I'm going to make the first case positive, and then the second case, let's make that 0. So what would I put here? We need two equal signs. So just a review that in order to compare a variable to another value, you need a double equal sign. So that actually represents the equality operator. One equal sign is called the assignment operator, and this is used to assign or to change a variable to a value. Okay, so if you want to put some data into a variable, you have to use one equal sign. So a common mistake is people use the assignment operator instead of the equality operator. So you definitely need two equal signs to represent exactly 0, and then otherwise this would be negative. Okay, so there are different ways to do this program, and it's important to know that there are different orders that you could use. Okay. All right, so, and then of course you could have you could have even more if statements. So let's say I change this to, let's say if A is greater than 80, then I'm going to say A. Else if A is greater than 70, then B. Okay, so you can see what I'm doing. I'm just creating a little grade program here that tells you the letter. Maybe this is confusing. Instead of A, I'm going to call this grade. And then I'll say enter a grade. Okay, and then we have a neat little grade program. This program appears in a lot of textbooks when they are teaching multiple alternative if statements. It's a classic program. So if grade is greater than 50, actually I'm going to change one thing. I'm going to say greater than or equal to 80, because of course if we get 80 right on the dot, then that's also an A. So that's a good review there. There's a difference between greater than and greater than or equal to. Okay, so we'll slap that on for all these. And then we're nearing the end here, so this is going to be a D. Notice also you don't put semicolons at the end of an if or an else if or an else. Okay. And then I'm just going to say else print f. So that basically means if all else fails. So if all of these things are false, then I'm going to print f. Okay, and now it's important to know exactly how this if block works. So it always starts from the very first expression, and it looks for the first one that is true. So let's say I enter 75 as my grade, then it checks this. Nope, that's false. It checks this. Yes, that's true. So it's going to print B, and then it ignores everything else. So the compiler won't even look at these expressions. So it will only print B, and that's it. And then this if block is finished. So that's the nice thing about using else ifs, is it combines everything into basically one chunk, one programming statement, and so it will only print one of these things. You have to be careful. If you did not use else, if you just used a bunch of ifs, then these are separate if blocks. And you can see in BlueJ it kind of separates with this line, like these are separate purple boxes. So if you don't use else ifs, it's really like you're doing this. You have separate independent if blocks. So what does that mean? Well, if I entered 75 as my grade, this would be false. This would be true, so it would print B. And then this would be true, so it would also print C. It would print both of those. And this would be true, so it would also print D. So in this scenario here, if I entered 75, it would print B, C, D, which is kind of confusing. So we don't want to do that for this particular program. I'm going to put my else's back in, and there we go. Now, there are some cases where you may want to have a bunch of if statements without the else ifs, and I think that might have come up during your tic-tac-toe program last year. Okay, so hopefully this all makes sense and is pretty straightforward. One other, well, there's a couple things I want to go over. Let's look at the modulus operator and how that can be used in if statements. So I'm just going to get rid of this, and I'm going to change this back to A and just say enter an int. And I'm going to have the user enter another int, a second one. And we'll store that into B. Okay, so you could do something like this. So you can use math operators like if A plus B, and you can use relational operators. So this is called a math or an arithmetic operator. And then this is called a relational operator, less than, greater than, equal to, not equal to. So I can say if A plus B is less than 100, then do something. Okay, I'll just print X. Else print Y. Okay, not a very meaningful program, but hopefully just illustrates the point here that you can mix and match. You can have arithmetic and relational operators. Now, the arithmetic will happen first. So precedence goes to arithmetic operators, and then finally we do the comparison. Okay, so it's going to add up A and B and check to see if it's less than 100. So if I run this and enter two numbers like 23 and 51, it just says X, which means the first if statement was true. Okay, another example using modulus, you could do something like this. If A mod B is equal to 0. Now, what that means, if A mod B is equal to 0, in other words, if you divide A by B, and if you get a remainder of 0, then that means that B is a factor of A. Okay, so I'm gonna put that here. B is a factor of A, or better yet, B concatenated with is a factor of the variable A. Okay, and then I'm going to copy this. Whoops. Whoop. Copy that. Actually, I'm just going to say, let me try that again. Copy and paste. Okay, and then I'm going to say B is not a factor of A. So here's an example. Maybe if you see me running it, it'll make a little more sense. So if I enter, let's say 24 and then 6. So it does 24 mod 6, and that should be 0. So it says, oh no, that's right. 6 is a factor of 24. Yes, that's right. But if I run it again and I did 24 and 5, then it says 5 is not a factor of 24. Okay, so there's kind of a neat little program to determine if one number is a factor of another number. Okay, we can also use something called logical operators in our programs. So I'm just going to get rid of this for now. So I can compare two things in the same if statement. So such as if A is greater than 0 and B is greater than 0. So this thing is called a logical operator. All right. So greater than, that's called a relational operator. These are called logical operators. So logical operators are used to combine two or more Boolean expressions together as one big expression. So basically, if both of these are true, so that's what and means. If both of these are true, if A is greater than 0 and B is greater than 0, then I'm going to print both are positive. Else, I'm going to say both are not positive. All right, so if I compile and run this, I can say like 8 and 9, and it says both are positive. But if one of those was negative, then it would go and say both are not positive. So if you're using and, it's pretty restrictive. It means that both of these Boolean expressions have to be true in order for the whole thing to be true, and then would print this statement. All right, now, if you use or it opens it up a little bit. So basically, if one of these things is true, then that means the whole thing is true. Okay, so the double vertical bar here means or, and it just means if one of these is true, then it means the whole statement is going to be true. Okay, now I pause there for a second because this statement doesn't actually jive now with this expression. So what I would say is something like either A or B is positive. Okay. And then down here, I can't really say both are not positive because that may not be true. So I'm just going to put X for now. Again, not the greatest example in the world, but I'm just illustrating and reviewing these logical operators with you. So I'm going to compile and run this. So this time if I say 6 and then -3, so either A or B is positive. Okay, because we're using the OR operator. Okay, so now you can combine. You can have several. You can have several logical operators. So if we're getting a little complex here, but let's say I add another input. So let's say there's 3 ints, A, B, and C. And then let's say I put if A is greater than 0 and B is greater than 0 or C is greater than 0. So now you got to think a little bit. I'm just going to put X and Y here. Okay, so now we have 3 Boolean expressions with two logical operators and an or. Now, so the question is, what happens first? What does the compiler do? Well, the compiler first does the Boolean expressions. So it first evaluates these to either true or false. Then it does and then it does or. Okay, so or happens last. So basically it's going to do this thing first, and then if that is false, if this whole thing is false, then it's going to check this third statement to see if that's true. So you kind of just read it like a plain English sentence here. So if A is greater than 0 and B is greater than 0, or C is greater than 0. Okay? So basically if I entered actually, you know what? To make this a bit easier, I'm not even going to have input. I'm just going to show you three numbers. So let's say A is 5, B is 7, and C is 2. Okay. So this is true, and this is true. So right away, this whole thing is true. This combined statement is true. And then that means we're going to print x. But let's say both of these were negative, just for fun. Let's say both of these were negative. So now this is false, and this is false. So this entire first expression is going to be false. But then we're saying or C is greater than 0. So now that's true. So that means the whole statement is going to be true because of this second piece. All right, that might have been a little bit complicated, but if you just read this kind of like an actual sentence, it hopefully makes sense. And then it's also important to know the order. So and happens before or. Okay, and then to make things just a tiny bit more confusing, there is a third logical operator called not. Okay, so that is the exclamation mark, and you would use it like this. So you would put an extra set of brackets, and then you put the exclamation mark here. And this looks weird, and it is kind of weird, but what this means is not C is greater than 0. Now, you're probably thinking, why would you ever do that? Like, can't you just get rid of the not and just change that to less than or equal to? And yes, you totally can. So C is less than or equal to 0 is the same thing as C is greater than 0 and then putting a not at the front. All right, so there's rare cases where you would need to use the not operator, but that is a third logical operator that we need to know about in this course. Okay, so if I were to read this out loud, it says if A is greater than 0 and B is greater than 0, or C is not greater than 0. That's how you read that. Okay, so that's a bit confusing, but that does exist. Okay, so all of these relational operators, greater than, less than, equal to, not equal to, all of them can be used with ints, doubles, chars, booleans. So they can be used with any primitive data type. Okay, so int, double, char, boolean. You can use greater than, less than, equal, not. You can use that for all primitive types. But what happens when you start to have strings? Okay, so let's say we have a string variable instead. Let's make two string variables. So things change a little bit when you have strings. So let's say this is cat and dog. Okay, so the moment you start working with strings, you can't use relational operators anymore. So you can't use greater than or less than or equal to. So for instance, this won't work. A is equal to B. If A is equal to B, that won't work with strings. Similarly, you can't use greater than or less than. Okay, so if you wanted to do equal to, we need to use the string method dot equals, which I think we're all aware of, and we're good with that. So what is this method? This is a built-in Java method, and it compares this string to this string. And if every single character is the same, then this returns true. But if there's something that's different, then it's going to return false. Okay, so in this case, it's going to be false. But if both of these were the exact same, then this would return true. What if this had a capital C here? Then this would be false. So it has to be a perfect match for that to be true. But there is another command called equals ignore case, which again you may remember from last year. And so that is nice. It ignores the case. So in this case, this would be true. All right. You can even do something like this. Again, it's a bit confusing, but you can put a not at the beginning. So this basically says if A is not equal to B. So if those two things are not equal to, then you're going to print X. Now you got to think about this. Let me change that back to dog. So think about this for a second. Is this going to print X or is it going to print Y? Well, is cat equal to dog? No. So this highlighted region would be false, but then we're putting a not at the beginning, which means this is now true, right? A is not equal to B. That is true. So it's going to print X in the end. Bit confusing, but with practice, hopefully it will make sense. So that is how you compare strings for equality to see if they are equal. And by using the not operator, that's how you determine if two strings are not equal to each other. And that can be used in like a password program that we did last year. The user gets to try and enter several guesses to try and get the password. So we actually used this not operator with a while loop in order to do that. We'll do that program again a little bit later. Okay, one more thing to show you, and that is how would you compare strings to see which string is less than another string? So in other words, can you do this? The answer is no. With strings, you can't say if this string is less than the other. You might ask, well, what does less than even mean? Like, does it mean the length of the string? No. What I want to compare is if one string is alphabetically less than the other. In other words, does cat appear in the dictionary before dog? So that's what we're talking about when we want to compare strings. So you can't use less than or greater than. So there is this command, there's a method called compare to. And this is probably something new. I don't think we studied compare to last year. Okay, so what does the compare to method do? Let me just illustrate with a little diagram here. So right now in my program, we have a string variable A that is cat. And remember how strings look in RAM. There's something called a reference, and it's pointing to an object. Okay, and then I also have B, which is storing dog. Okay, so if I said A dot compare to B, this is a built-in Java method called compare to. What it does is it looks at the first letter of both strings. So we have a C and a D, and it looks at their ASCII codes. So the ASCII code for lowercase a is 97, I believe. So lowercase c would be 99, and then lowercase d would be 100. Okay, I think I'm correct in saying that. So what the compare to method does is it takes the first characters and it subtracts their ASCII values. So it's going to subtract 99 minus 100, and it gives you back the result. So in this case, it would be -1. Okay, so the compare to method, it takes the first characters and it subtracts their ASCII values. Now, in what order does it subtract? Well, the order that you put the variables here. So if the first string is A, it's going to take 99 and then subtract 100. And so this would give you an answer of -1. Okay, so if I went back to my program, the compare to method gives us something back. It gives us an integer back. So I could say something like this. If a dot compare to b is less than 0, then I can say first string is alphabetically less than the second string. Okay, so if you use the compare to method and it gives you a negative value, it means that this string comes before this string in the dictionary. All right, and then I can just kind of copy this, paste, and if it goes to the else, then I'm going to say second string is alphabetically less than the first string. Okay, let's look at another example. So what if I had like dog and then door? All right, so what if my strings were dog and door? In other words, what if the first characters are the same? Well, the compare to method is pretty smart. So let me just change this to dog and door. Okay, so what compare to does is it looks at the first letter and it looks at the ASCII codes. So that would be 100 and 100. So it's a tie. So what it does is now it goes to the second character. And I'm not sure what that is. Let's just say it's 112. Okay, 112. And that's a tie as well. So it goes to the next one. And now we have 112 down here. And up here we have, what, 103 maybe? Okay, so now it finally does the subtraction. So the compare to method has a little loop built into it, and it basically it keeps searching until we find two characters that are different, and then it subtracts the ASCII values. So in this case, I would do 103 minus 112 for a total of -9. Okay, so that's how compare to works. It looks at the first characters in each string, and if they are equal, it goes to the second, and if they're equal, it goes to the third, and it keeps going until it finds different characters, and then it subtracts their ASCII values. Okay, so the compare to method is a nice way of determining if one string is alphabetically less than another string. Okay. A bit confusing, perhaps. We'll practice this a little bit and see more examples. We did a lot in this video. Not only did we review if statements, but we reviewed strings and how to compare them, whether for equality using the equals method or the compare to check to see if one is alphabetically less than another. You might ask, why is this important? Like, why do we need to even know this? When would we ever need to know if one string is alphabetically less than another? Well, I'll tell you, very soon we're going to generate a list of many, many random strings, and then we want to sort them. We want to put them in sorted order. Because if you can sort data, then you can search through it quite quickly. And that's kind of where we're headed in this course. So I hope this makes sense. Thanks very much for watching. Practice your work and ask me if you have any questions. Okay.